Hello, welcome to the video. In this lesson, we're going to be looking at section 8.5, where we're going to be using recursive rules with sequences. So there are two different ways to write a rule when it comes to sequences. Whether it's, whether it's arithmetic, whether it's geometric, or whether it's neither of those two things. What we've been doing uh, for the last couple of lessons is looking at what are called explicit rules. All right, explicit rules give us um, a value for whatever term of a sub n is with respect to the function in terms of its position in the sequence. So we can pick any term in the sequence and we can get a value for that when it is explicit. When it's recursive, when it's recursive, what is happening is we are giving the beginning term of a sequence and we are being able to relate whatever a sub n is going to be with respect to one or more preceding terms. So the problem or the issue with recursive rules is in order to figure out what, like, say, like, to find like the fifth term in a sequence, in order to find that fifth term you need to know what the fourth one is, or possibly third. So you're going to have to know some terms prior to that in order to um, figure out the term that you're looking for. So here is uh, here is a rule with a recursive rule with respect to knowing what this first term is. In this case, is a sub 0. So they want us to find the first six terms. Since they give us a sub 0, we're going to find a sub 0 in this case, a sub 1, a sub 2, a sub 3, a sub 4, and a sub 5. So these are six. 1, 2, 3, 4, 5, 6. So these are the first five terms. A sub 1 we know is 1 because they gave that to us. A sub 1 is going to be a sub n minus 1, which is a sub 0, so it's the previous value, so it's 1 plus 4, which equals 5. We go to a sub 2, we go to the previous one, which is 5, so it's going to be 5 plus 4, which is 9. A sub 3 is going to be 9 plus 4, which is 13. A sub 4 is going to be 13 plus 4, which is 17. And then finally, a sub 5 is 17 plus 4, which is 21. So here are the first six terms of the sequence, a recursive with respect to the recursive rule of a sub n minus 1 plus 4. Okay. For part B, here they say f of 1. So actually, I'm just going to call this a sub 1 just to keep it consistent with what we've been talking about throughout the course of this chapter. So they give us essentially a sub 1, which is 1. Here, what we're going to do, it's going to be 3 times it by n minus 1. Well, n minus 1 was 1, so that's the previous one, so that's 1, so that equals 3. Here it's going to be 3 times it by 3, which is 9. Here it's going to be 3 times it by 9, which is 27. Here it's going to be 3 times it by 27, which is 81. And then finally 3 times it by 81, which is 243. So here are the first six numbers of the sequence, and we were able to gain those six terms because we were able to use the previous term as our value for the next term in the sequence. All right. Again, these are very similar situations trying to find the six terms. Again, if you have questions, please let me know. I'm more than happy to answer those if need be. So what we have is we also have um, a recursive equation for both arithmetic and geometric sequence. If it's arithmetic, if it's an arithmetic sequence, which means that it has a common difference, you are going to figure out what a sub n is by taking a sub n minus 1 plus d. To find a geometric sequence, again, you have to have a common ratio. This one's going to be a sub n is equal to r, the common difference, times it by a sub n minus 1, the previous term in the sequence. So here they're asking us to write a recursive rule. So since they want us to write a recursive rule, the first thing we have to do is determine if the sequence has a common difference or a common ratio. So first thing I'm going to do is I'm going to subtract these two. If I subtract these two, I get 10. If I subtract these two, I also get 10. Oh, I subtract these two, I get 10. So I'm led to believe that this is an arithmetic sequence and the common difference is 10. All right, now when we write a recursive rule, I need to know the first term here. So it's going to be a sub 1 is equal to 3. And then the rule is going to be a sub n is equal to a sub n minus 1 plus the common difference, which is 10. And there's my recursive rule. Here, first thing I'm going to do is I'm going to see if it has a common difference. 40 minus 16 is 24. 100 minus 40 is 60. All right, so it doesn't have a common difference. Let's see if it has a common ratio. So 40 divided by 16 is 2.5. 100 divided by 40 is 2.5. So what this is it has a common ratio of 2.5, so it's a geometric sequence. So now I know that a sub 1 in this situation was 16, and my rule is going to be a sub n is equal to the common ratio, which is 2.5, and it's going to be multiplied by a sub n minus 1. And here's my recursive rule. All right. Here, looking at this one, these two examples, if I took the common difference, I get 0. If I took the common difference, I would get 1. All right, so it's not the same. So let's take a look at common ratio. So 1 divided by 1 is 1. 2 divided by 1 is 2. All right, so now we have a situation where it is neither a arithmetic or a geometric sequence. Normally, normally what it means is what we're going to have to do is there's a possibility that we have to use two terms in a sequence to write a rule, or it's something where we're going to use our term n with respect to the next term to be able to figure out what our rule will actually be. So if we look at example A, I get 1, I get 1, I get 2, I get 3, I get 5. So what I notice is if I took the first two terms, 1 and 1, if I added them together, I'd get 2. If I took this term and this term and added together, I'd get 3. Here, if I took this term and this term and added together, I'd get 5. So what I'm led to believe is that for this particular example, we're going to be need using two terms in order to establish the next term in the sequence. So we're going to write in a sub 1 is equal to 1, a sub 2 is equal to 1, and then the rule a sub n will be, since you just add up the two, so it's going to be a sub n minus 2 plus a sub n minus 1. So if like I'm just trying to find this one right here, 5, so a sub 5, for instance, you would say, oh, a sub n minus, so 5 minus 2 is 3, 3 is 2, plus a sub n minus 1, so 4, so that would be a sub 4, that would give me 3. So that's how I could say that's 2 plus 3. So this is my rule, okay? Looking at the second example, it gives me 1 and 1 again. All right, so if I did, oh, 1 plus 1 is 2, that makes sense. Now, what if I wrote in 1 plus 2, does that give me 6? No, so it's not the exact same thing as the original one, but let's say if I did something like, if I multiplied, so like 1 times 1 is 2, then oh, that doesn't work out. But let's think about it this way. This is the first term in the sequence. This is the second term in the sequence. Third, fourth, and then fifth. Do we notice something? Well, if I look at this, let's say I multiplied these two values together. 1 times 1 is 1. Oh, 1 times 2 is 2. 2 times 3 is 6. 6 times 4 is 24. Well, where did I get these values of 1, 2, 3, 4, and 5? Those are all our values of n. So what I'm going to do is we only need to write in one term, so that's a sub 1 is 1. And our rule for this particular sequence is going to be whatever n is, and it's going to be multiplied by a sub n minus 1. All right, so here they're asking you to write a recursive rule when you know what the explicit rule is. So looking at this first one, a sub n is equal to negative 6 plus 8n. This is an arithmetic sequence rule. So the first thing you got to do is you got to figure out what a sub 1 is. A sub 1 is, so you just simply put 1 in for n. Negative 6 plus 8 is, what, 2. So I know that a sub 1 is 2. All right, from here, I need to figure out what d is. All right, I need to figure out what the common difference. Well, since it's being multiplied by 8, I know that my common difference is 8. All right, so now, knowing that a sub 1 is 2, I can figure out my rule using the recursive rule, knowing that it is arithmetic. I can say that it is going to be a sub n minus 1 plus 8, and I know that a sub 1 is 2. Looking at the second example here, a sub n is equal to negative 3 times it by 1/2 raised to the n minus 1 power. What I notice is, oh, this is my a sub 1. Oh, this is my common difference. So now I know that a sub 1 is negative 3. I know that my common ratio is 1/2. Using the formula for recursive rule for geometric, I know that a sub n is going to be equal to r, which is 1/2, multiplied by a sub n minus 1. So that whole part is the answer. So again, here, now they want you to write an explicit rule for each sequence. But what they give us is they give us a recursive rule. But they tell us what a sub 1 is in both examples. So this case, a sub 1 is negative 5. So knowing that this is arithmetic, using the rule from previous sections, I can say, well, a sub n is going to be equal to a sub 1, which is negative 5, plus n minus 1 times it by the Common difference, well, the common difference is -2. So now I just distribute the -2, so -5 plus -2n plus 2. So my rule is -2n minus 3. There's my explicit rule. Here, it is geometric, but I know what my a sub 1 is, and I also know that my uh, common ratio is 2. So knowing that it's geometric, I can say that, oh, a sub n is going to be equal to 2. I'm sorry. Yeah, it's going to be equal to, sorry, it's going to be equal to 10, which is a sub 1, times it by 2, which is the common ratio, and it's raised to the n minus 1 power. Yep, that's what it is. All right. Final example here, it says a lake initially contains 5,200 fish. Each year, the population declines 30% due to fishing and other causes. So the lake is restocked with 400 fish. Here, they're asking us to write a recursive rule for the number a sub n of fish at the start of the nth year. So how we are going to write this rule is, first we need to figure out what a sub 1 is. Well, a sub 1 is how much fish started out, and that was 5,200. All right. From here, they told us that 30%, the population declined 30%, which means that 70% of the fish remain. So what we are looking at is we are looking at a geometric sequence. All right, but it's a recursive rule. So what we're going to do is, in order to write this rule, it's going to be a sub n is going to be equal to the common ratio, which is 0.7 in this case. It's going to be multiplied a sub n minus 1. But they also added this other thing where they restock at 400 fish or whatever it is. We're going to add 400 fish to that total. So this is my recursive rule for the nth year. So then the second question is they want you to find out the number of fish at the start of the fifth year. So for year one, it's 5,200. So if I go to year two, let me, so if I go 5,200 times it by 0.7, enter that, and then add 400, I get 4040. Here, I take that number, multiply it by 0.7, get enter, add 400. I get 3228. And then multiply that by 0.7, enter, add 400. I get like 26, that's 60. And then multiply that by 0.7, add 400. I get 2262. So that's the fifth year. So about 2,262 fish will start the fifth year. Okay. The last question here says, describe what happens to the population over time. So what we're going to do is, so what we have here is the 2261.27. That's after 5 years. So what I want to do is I want to see over time if this stabilizes. So if I, again, multiply by 0.7, add by 400, I get what looks like 1983. Times that by 0.7 plus 400, I get 1788. Times it by 0.7, add 400, 1651 times 0.7 plus 4, oops, plus 400. So 1556, still going down. Now we're at 1489, still going down. All right, still going down just a little bit more. All right, we're still going down. Let's see what we got here. All right, so now we're at 1386 times 0.7 plus 400. Now we're at so now the gap between like 1386 and 1370 is much less. So let's see what it looks like coming up. Oh, now we're getting less of a difference. So now we're at 1351. Again, that was only 8. Let's see what happens here. Again, that was. So now if you notice that the gap each year is not as much. So like now we're at 4. You know, again, 3. So let's try one more time. So, you know, again, it feels like it's getting less and less, you know, the gap's getting less and less. So if I did it one more time, that's only 1. So, you know, you could say something like it kind of stabilizes in that 1336 range. Just see what happens if I do it one more time. All right, so it's just 1. See if it happens again at 1. Yeah, so it looks like it's in that 1330. I would say that it's going to, again, it's going to stabilize around that 1300 range, or 1330, I'm sorry, over time. And that is being able to use the recursive rule with sequences. I hope this helps. Until next time.